What's up, guys? I just posted the pre-release of this project called ACT. Stands for Anti-Cheat Telemetry. So basically what the idea was behind this project is to basically create a mock anti-cheat that allows you to see what detections it has found. Most of the time this is going to be used for games, which is why it's an anti-cheat. So I'm just going to go through and I'm going to show you guys how you can use this. So down here I have some instructions to build this project with CMake, but I'm going to go the easier route and go ahead to our releases tab where we have a installer. So now that I have the installer open, I'm going to just click install and then I'm going to launch ACT. So here is the ACT UI. Let's go ahead and open up a game. So let's go Sauerbraten. This is a 64-bit game. Right now we're only supporting 64-bit applications. Maybe that will change in the future, add some more compatibility, but for right now we're just sticking to 64-bit games because it is 2026. So yeah, so we're in a match right now, and let's go and look at the act loader here and search for Sauerbraten. You'll see that it's not here right now, so we'll just refresh and then we'll click on Sauerbraten. Now, it has injected the ACT DLL into the game. So, you'll see as we inject in, there's actually a lot of output in our console right now. It's kind of hard to heuristically determine what is supposed to be there and what's not. So, we just made it so that you can remove flags if you think that they're unnecessary. The same flag can reappear as long as it's showing up with a different set of data here. So like for example, you can get another new module failed trust verification log, and it'll trigger the detections up here on the top, but it will not do this exact same print again. Okay. So let's go ahead and remove all of those flags. And I'm going to go and use Process Hacker to inject a cheat into the game. Alright, so I just injected the cheat into the game. And you can see that it's working fine, like it's silent aiming. And if we go back here, you'll see that we have three flags that appear. So Process Hacker is going to be load librarying. So it's not going to be manual mapping. You'd probably get a lot more detection vectors if you were manual mapping. But basically, a new module appeared on the module list, and it failed the trust verification because it's an unsigned DLL. And we can also see here that it detected an executable page not belonging to a valid module. So I'm assuming this is maybe some shell code from Minhook, because I know that this cheat uses Minhook. Well, I created the cheat, but yeah. And then we over here finally see that the hash changed in the .text section of the game because we are minhooking, we are hooking a game function. So these appear down here, and here is a short and more straightforward detection list. So if hashes change in multiple locations, it'll just appear up here once that that the PE section hash is mismatched. But now let's go ahead and try manual mapping. So I'm gonna reset up this all, and instead of using Process Hacker, I'm gonna manual map. All right, so this time I manual mapped it. So you'll see that we have actually a different set of detection vectors, being that a thread handle failed to open. We have a start address of a thread from a invalid region of memory, and it gives you the invalid region of memory. We've detected two executable pages that are not belonging to a valid module. Once again, I think one of these is going to be a minhook shellcode allocation, and the other one is going to be probably the allocation of the actual DLL itself. And then last but not least, we also have that the hash changed in the .text section. Now, once again, there is going to be way more detection vectors in the future, but we are also not triggering that many detection vectors right now. There actually are plenty of detection vectors right now, like DirectX vtable validation. This is not a DirectX game, so we didn't do anything like that in here. And honestly, a good deal of things that can actually be found on the GitHub or by just searching through the code itself. If you go to the flags.hpp inside of the source folder, you'll see a list of the actual flags that we have in an enum, and you can actually see what are the flags that are being triggered, or what are the flags that can potentially be triggered. But yeah, so that's a simple explanation of how to use ACT. and have fun trying to bypass these detection vectors.